For 400 years, Mayon Volcano has followed a script. Smoke, rumbles, lava from the crater, evacuate, wait, rebuild, repeat. But this week, the volcano rewrote its own playbook. The 3-kilometer ash plume that erupted on February 14th looked routine at first, textbook Mayan behavior. Then scientists spotted the anomaly. Thermal cameras picked up lava flows emerging not from the summit, but from fissures splitting open along the mountain's midsection. These were not old vents reactivating. They were brand new fractures, tearing through rock that has been solid for decades. And as 10,000 people evacuated surrounding towns, seismologists made an even more disturbing discovery. The tremors shaking Mayon aren't following the usual eruption pattern. They're deeper, more sustained, and they're concentrated beneath the southeastern flank, the same side now glowing with fresh lava. It's as if the mountain isn't just venting steam, it's restructuring itself in real time. So here's what keeps experts awake at night. If Mayon is breaking its centuries-old eruption cycle, does anyone actually know what comes next? To understand what might be happening at Mayon, scientists are looking thousands of miles away to Hawaii, because what is unfolding in the Philippines carries echoes of a volcanic event that rewrote the textbooks just 8 years ago. April 30th, 2018, the Pu'oo crater floor at Kilauea Volcano suddenly collapsed, sending magma racing down rift beneath the surface. Within days, eruptive fissures opened in the lower East Rift Zone on May 3rd, eventually extending nearly 7 kilometers. But here is what made Kilauea's 2018 event unprecedented. The lava lake within the summit caldera began draining like a bucket with a hole in it, falling more than 200 meters within days. And as magma drained from the summit, the unsupported caldera floor began collapsing in massive chunks, dropping more than 500 meters over the course of 3 months. The most shocking discovery came later. Researchers found that this dramatic collapse was triggered by only a small leak of magma from the reservoir beneath the peak, less than 3.5 to 4% of the total volume. Dr. Kyle Anderson of the USGS put it this way: the eruption caused the caldera collapse, not the other way around. Once magma started draining through fissures lower on the mountain, the summit had no choice but to follow. Over the next weeks, up to 700 earthquakes occurred between each summit collapse event, culminating in near daily magnitude 5.2 to 5.4 earthquakes. More than 60,000 earthquakes accompanied the summit collapse, during which the caldera deepened by more than 500 meters. The lesson? When a volcano's magma finds a new escape route, the entire mountain can restructure itself in a matter of months. And that is exactly the pattern Mayon might be starting right now. The similarities between Kilauea's 2018 eruption and Mayon's current activity are striking. Both volcanoes are known for their picturesque, symmetrical cones, but beneath that beauty lies a complex network of magma pathways. When those pathways shift, the consequences can be catastrophic. Kilauea's collapse was a stark reminder that even well-studied volcanoes can catch scientists off guard. The mountain had been erupting continuously since 1983, but no one anticipated the scale of the 2018 eruption. The lava lake within Halemaumau crater, which had been bubbling for years, suddenly drained away. The crater floor collapsed, forming a new caldera nearly as deep as the Empire State Building is tall. Magma diverted from the summit tore open new fissures in the lower East Rift Zone, destroying hundreds of homes and burying miles of highway. By the time the eruption ended in August, Kilauea had disgorged enough lava to fill 320,000 Olympic-sized swimming pools. It was the volcano's largest eruption in over 200 years. Now, as scientists watch Mayon closely for signs of a similar pattern, they are acutely aware of the stakes. Mayon Volcano rises more than 2,400 meters above sea level on Luzon Island, forming an almost perfectly symmetrical cone. That symmetry is not an accident. It is evidence of Mayon's relentless consistency. Historical records indicate Mayon has erupted 65 times in the past 5,000 years. That is roughly once every 77 years. But in modern history, the volcano has been far more active, erupting dozens of times since detailed record-keeping began in 1616. And here is what makes Mayon predictable, until now. Its eruptions typically follow a clear sequence. Stage 1. Ground deformation. The mountain swells as magma rises. Stage 2. Summit activity. Steam and gas emissions, then lava visible at the crater. Stage 3. Lava flows. Molten rock pours from the summit, following gravity down established channels called gullies. Stage 4. Pyroclastic density currents. Superheated avalanches of rock, ash, and gas that race down the slopes. Stage 5. Gradual decline. Activity tapers. The volcano goes quiet. Communities rebuild. This pattern has repeated for centuries. Scientists could predict which communities were at risk based purely on where lava had flowed before. But Mayon's eruptions, while predictable, have never been safe. In 1814, pyroclastic flows killed approximately 1,000 people. In 1897, over 400 died from similar flows. And even in recent decades, the volcano has shown it can kill with little warning. In January 2026, the current eruption began, when the Philippine Institute of Volcanology and Seismology first reported increased rockfalls near the volcano's summit and inflation of the mountain's upper slopes. On January 6th, the alert level was raised to level 3 on a 5-level scale after lava began flowing from the crater. For weeks, the eruption behaved exactly as expected. Lava fountains, rockfalls, pyroclastic flows confined to known danger zones. Evacuations proceeded smoothly. By March 10th, approximately 4,058 people had been evacuated from 13 emergency shelters. But then came the signals no one anticipated. On March 19th, 2026, day 73 of the effusive eruption, PHIVOLCS observed something unusual. Lava effusion with collapse occurred on the Mai Gully. That alone was not alarming. Collapses happen. But thermal imaging told a different story. Satellite sensors began detecting heat signatures, not just at the summit, but spreading across multiple gullies simultaneously. As of March 19th, lava flow lengths remained at 3.8 kilometers in the Basud Gully on the eastern flank, 3.2 kilometers in the Bonga Gully on the southeast flank, and 1.3 kilometers in the Mi Isi Gully on the southern flank. 3 separate lava flows were radiating from different parts of the volcano. That is not how Mayon typically erupts. The anomalies did not stop there. On March 9th and 10th, a total of 335 volcanic earthquakes were detected at the volcano, with the majority scattered around Mayon's crater. By March 19th, seismometers recorded 412 rockfalls in a single day, but the earthquake pattern itself was wrong. Instead of shallow tremors clustered near the summit, the normal signature of lava pooling before an eruption, instruments were picking up deeper, more sustained vibrations beneath the southeastern flank. An episode of tremor lasting 2 minutes was recorded on March 19th, the kind of sustained shaking that suggests magma is not just erupting, it is forcing its way through new pathways. Gas emissions told a similar story. Sulfur dioxide emissions during the current eruption averaged 2,466 tons per day, with a peak of 6,569 metric tons measured on February 4th, the highest single-day sulfur dioxide emission level in 15 years. Then on March 6th, emissions reached 7,633 metric tons, shattering the February record. On March 9th, PHIVOLCS measured sulfur dioxide flux at 5,875 tons, one of the highest emissions recorded this year. When a volcano suddenly releases record amounts of sulfur dioxide, it means fresh magma is degassing near the surface. And when those spikes keep climbing, it means more magma is arriving than the volcano can vent through normal channels. The ground itself was shifting. By mid-March, GPS stations around Mayon began registering something seismologists call inflationary deformation. The mountain was swelling. But the deformation was not uniform. It was concentrated on the southeastern flank, the exact side where new lava flows had appeared. Scientists reviewing thermal imaging data made a discovery that changed everything. The lava emerging from Mayon's midsection gullies was not overflow from the crater. These were new fractures, tearing through the mountainside as magma forced its way through weakened rock. It was the same mechanism that triggered Kilauea's collapse in 2018. Magma finds a new path. Pressure redistributes. The volcano restructures. And the clock starts ticking. As the eruption enters its 4th month, the stakes could not be higher. Alert Level 3 remains in effect, meaning entry into the 6-kilometer permanent danger zone is strictly prohibited. Residents living within an 8-kilometer radius are advised to remain prepared for possible evacuation should monitoring parameters escalate. But here's the problem. Those danger zones were drawn based on Mayon's historical eruption patterns, lava flowing from the summit down predictable channels. If the southeastern flank is now venting magma independently, the danger zones might be obsolete. PHIVOLCS has already identified Tabaco City, Malilpot, and Kamalig as affected areas where temporary displacement has forced hundreds of families to leave. But communities on Mayon's southern and eastern slopes, areas not typically threatened, are now directly in the path of emerging lava flows. The risk is not limited to lava. Between February 8 and February 9, PHIVOLCS reported a peak in activity with 469 rockfalls and 12 major pyroclastic flows. Recent observations showed pyroclastic density currents producing brownish-gray ash clouds that rained ashfall on communities on the southwestern slopes. When lava flows from multiple flanks simultaneously, the risk of pyroclastic flows multiplies. Each flow can collapse, generating superheated avalanches racing downhill at speeds exceeding 100 kilometers per hour. And unlike lava, which moves slowly enough to evacuate ahead of them, pyroclastic flows give no warning. The potential for a prolonged eruption is also a concern. PHIVOLCS Director Teresito Bacolco noted that effusive eruptions can last for weeks or even months, as long as magma continues to reach the surface. In 2023, Mayon's effusive eruption lasted 6 months. But if Mayon shifts from effusive to explosive eruption, the impact would not stay local. Ash plumes have already reached 1,400 meters above the vent. A full explosive event could send ash columns tens of thousands of feet into the atmosphere, disrupting air traffic across Southeast Asia and blanketing Manila, 120 kilometers away, in volcanic dust. The economic cost of a prolonged eruption affecting the Philippines' largest city would be catastrophic. As Mayon's eruption continues, the scientific community is racing to understand the implications. The pattern scientists have relied on for centuries is breaking down. The southeastern flank is venting magma. Sulfur dioxide emissions are shattering records. Seismic activity is migrating deeper, and the mountain is swelling in ways that do not match historical norms. When Kilauea broke its pattern in 2018, it took less than 4% magma drainage to trigger catastrophic summit collapse. Mayon's internal plumbing is different, steeper, more pressurized, built on a different tectonic foundation. But the mechanism is eerily similar. Magma finds a new path, the summit drains, and the structure fails. The question haunting volcanologists now is not whether Mayon will follow Kilauea's example. It is how long before the mountain decides for itself. Because right now, beneath the perfect cone that tourists photograph, beneath the villages and rice fields and evacuation shelters, the volcano is rewriting its own rules. And when nature breaks a pattern it has kept for 400 years, no one can predict what comes next. As ash continues to drift over Albay province and lava glows against the night sky, one question echoes across the Philippine volcanology community. Are we watching an eruption, or are we watching a mountain preparing to collapse? Subscribe to Earth Attacks for real-time updates and expert analysis as Mayon's crisis continues to unfold. When volcanoes break their patterns, science races to catch up, and we will bring you every development. Click the link to join us on the front lines of Earth's most unpredictable forces.